All right, so yeah, take two, action. Okay, so good morning, everyone. My name is Balázs Keszthelyi. I'm the founding CEO of the consulting company Technolinks, and I'd like to specifically mention two of my colleagues, Miklós Fokin and Levente Gönc, who, with their work on the background research, contributed more to this presentation than I did so far. So. Obviously, all of us have heard in the news many times stories about some horrible, racist, xenophobic AI solution that if it was unleashed on the society, then it would obviously wreak havoc. So most of this presentation is going to be about the discussion of specific events and articles and a humble attempt to somehow put a bit of an order behind this topic. So as a starting point, I would do a bit of terms and definitions. I think this part is necessary because I found that out there are many names for pretty much the same or similar concepts, and actually not using the not having clarity with the names is a very good way of hiding the significant difference between them. So in this presentation, I'm going to use correlation just in the most general sense that something is a function of some feature. So we don't care about direction of the correlation. We don't care about proportionality, nothing at all. So just some sort of functioning is sufficient. Bias here is specifically defined as something against the prediction error, which is something that's going to be very important in the particular cases. So I brought an example for both cases. So correlation is something where, for example, the body mass index is a good indicator of a metabolic disorder if it is high. So that's a correlation. However, bias is when a predictor where a positive outcome is actually indicated as a positive numerical value. So if it's having more false negatives for women than for men, then that is actually likely a bias. However, there are cases which I would classify as faux bias, which sounds as if it was a bias, and you can write a very nice article about it to scare people, but in reality, that is just correlation. So one example is the one that I just highlighted there. So I try to use the least divisive language for basically saying that if you can give birth, then probably you have a higher chance to give birth than someone who cannot. So it is also important that from these definitions alone, it's not yet clear, but in general, the bias and the faux bias dimension of the discussion is going to be quite related to the other argument that is going on, not in the technical community as much, is basically the difference between the goals. So what do we actually want to achieve here? So whether we want equal opportunity, and that's how we would measure success in a fair society, or we want to achieve equal outcome. These two are also known as equality versus equity. I prefer these because for non-native speakers, I believe these are more clear wordings. Okay, so let's start with a couple of famous controversies out there. So one was in the US that for a government project, they tried to establish in the criminal justice system a predictive system that could predict the chance of recidivity. So basically how likely it is that once you committed some sort of crime, then you are going to do it again. And this one, I would say, is a good example of bias detection, because here the argument was that the model predicted twice as many false positives for black offenders than for white offenders. So the important part here is that I actually dug up that even for this case, there were articles who were putting the emphasis on argument like how many more cases there were when the system predicted that black people is going to fall back to crime again rather than white people. However, the issue with these kind of statements is that it doesn't deal with the fact that what if it is actually more likely. So this one is way clearer. So in this particular case, because it is focusing on the error of the prediction, it is something we can actually argue that it's likely a correct identification of bias. Most of my, okay, sorry. So before going further, so I bring examples for particular wording from another topic, which was credit assessment. So basically, there is one assumption that the algorithm may learn that men are more creditworthy than women because historically more men were given loans than women due to societal biases. So alone, this sentence is factually correct. I mean, a long time in history, women couldn't even have a job basically, or they were not allowed to be the breadwinners in any family, and so on and so forth. So just if long enough data is taken into account, then it is true that there is an obvious bias towards men. Now, here's another example of obvious bias. So basically, although it's not statistically significant, but basically two exactly identical applications from husband and wife, one gets rejected, the other gets approved. So this is a case where we actually know that all else being equal, yet the outcome was different of the prediction. So this is something that is likely a sign of bias. But here I have to highlight another thing, is that in our domain, which in this specific case would be deep learning, this is fairly known that in any data set, if there's a clear disparity between the frequency of certain cases, so for example, over a long enough window, there are just fewer successful women credit history than men, then an imbalanced training problem will materialize. So this is in general a problem that should be and generally can be addressed either with undersampling, so basically ignoring some samples from the majority category, or oversampling, which is like artificially introduce even the same samples from the minority category more often during training. Now, here comes a more interesting one. So the Amazon hiring algorithm. So this is something that has been in use or wasn't in use, because actually by now, based on Amazon's statement, it's not even clear whether this was a system that has been developed internally and then it wasn't used, or it was a system that was just put out of use after the surfacing of some controversy about it. So I tried to dig up some actual relevant data about what happened there, but unfortunately I can only have my theories about it. So one thing is that this is the typical case when so basically the argument is that the hiring algorithm was biased against women, and specifically for technical staff roles. However, at least for this particular case, I didn't manage to find any actual data to back up the claim. Also, unlike many other FANG companies, Amazon is not actually publishing either success rates or employment rates on a gender basis for technical roles specifically. They have a total headcount gender proportion metric, which is about 60-40 favoring men, but we don't actually know the technical one. At least
Everybody has a baby outside.
Okay. All right. Anyway, hi, little guy. So, sorry.
Who is
Nem is láttam már.
Maybe that was a question.
Esetleg,
Oh, yeah.
Oh,
I'll take questions at the end.
már nincsen benne. A srácoknak adnak a co-hostot.
Right. So basically, these two statements are examples of one, which is like an unqualified statement. So it's found to be biased, but there's no argument as for what kind of bias and so on and so forth. However, again, as usual, there is at least an identification of a potential source of bias. So that obviously, if you train a system, again, so this, if you make it to be an imbalanced training problem, like for technical roles, you have like, I don't know, over 80% of your candidates in the first place being men, and probably there will be some kind of bias introduced to the system. So that is actually correct. But it's like a probably not found to be biased. Sorry. Okay. So later, and that's also quite typical in these articles, that they put in some charts, as I said, the one which is arguing that at FAANG companies, 80% of the technical staff are men, but they completely ignore the aspect of looking at any other feature or any other skills, talents, past experience, and so forth for candidates. So basically, they are focusing on the outcome rather than any property that could be assigned either to the AI predictive system or just the recruitment process in general. So this technically is a false bias argument, which doesn't mean that Amazon's hiring algorithm wasn't biased, as we will soon see, but there were other problems as well. So basically, more digging and more on the interview side, this article even turned out to be useful from Reuters, because it turns out that this specific hiring algorithm wasn't even any good in the first place. So the big learning was, and this is something that with almost 10 years of recruiting technical talent, I can also well, feel, is that CVs alone are not very predictive. So the thing is that the system may or may not have been any gender-based bias or race-based bias or any other kind of social bias, but its output nonetheless, other than some basically replicating some of the previously already known proportions in the decision. So other than that, it was making pretty random decisions, which, as I said, in my experience, is not fundamentally different than, I don't know, filtering done by most recruitment agencies, for example. So ultimately, this story is probably much less about bias than about an inappropriate AI application, which is unfortunately quite common out there when people try to find a problem which is genuinely difficult to predict and solve. And probably it's not actually solved by human operators either before, but then we just hope that if we unleash AI on it, then it will have some better results. There are cases when it has, but there are cases when it doesn't have better answers. Another nice one is the not colorblind. So it's an actual paper. So basically what they found is that even if they did put in effort to hide the differences between the retinal scan of black babies and white babies, they found that it was still possible so basically they first hide the differences with the operations in color space, then they apply a segmentation routine on top of it so that they end up being having a segmentation map of the veins, and then they built an AI which was trying to predict the race, which was by intention hidden for the system. So they tried to predict the race from the output, so basically just from the segmentation. And they found that actually it was still quite possible to back predict the race of the patient, as I said, despite actual attempts to hide that feature. And what was a bit, very worrisome in this paper for me is that although the authors with some directed questions, they revealed that it is actually possible that correlation was found because there is correlation. It may be imperceptible to human observers, but actually there may be structural differences in the veins that is indicative of the race of the patient. But it was mentioned almost like, yeah, probably, but it's not very likely, and so on and so forth. So basically the existence of bias in this example and paper was effectively just assumed and accepted as the more likely scenario, rather than without actually backing it up with any sort of data and so on and so forth. So here I would say and bring an example from another domain, because obviously if we talk about something like differences between people of different race, then that's always an inflammatory topic, so to say. So I would bring that discussion into another domain. So for example, if I've been working in the video compression industry for a while. So if you try to do A/B testing with humans, looking at the actual uncompressed video stream versus a very, very, very high quality but lossy video stream, then practically no one, even the experts, are able to actually tell the difference between them, especially if it's motion picture. Still images are easier, but motion picture is tricky. Now, this is something that AI algorithms, on the other hand, are very capable, and they can very easily distinguish the difference even between high quality video versus uncompressed. And as a matter of fact, they can learn in that domain structural differences, which are so basically, why is that important is that they don't even need a reference image. So just by looking at the image alone, so not even A/B testing, they can tell the difference, because a structural noise is a sort of correlation you can tap onto. So I'm just bringing that example up because it's pretty clear that there are cases out there when AI can see things that we don't. Okay, so even in the metrics that are meant to, enable us to measure the amount of bias in the system, there are notable examples that are biased themselves. So disparate impact is a pretty good one. So if you just look at it on the, from hindsight, then this idea of having the probability of positive outcome for the privileged, and you're looking at the ratio of that, here's the probability of positive outcome versus the unprivileged. So yes, as I said, in hindsight, you could say that, yeah, if this thing is kind of close to 1, then we should be happy about ourselves. But if we actually start thinking about it, then basically the whole thing will depend on whether our assumption about privilege was correct in the first place. So if the features that we believe to be, exclusively indicators of privilege, but in reality not indicators of performance whatsoever, then this metric is correct. However, if we were wrong about it and we assumed that, okay, we shouldn't have, correlation in this and that dimension, so that we just classify as privilege, and we are looking at everything else, whilst in reality there was correlation, then basically optimizing this metric will be quite detrimental to the performance of the algorithm. And basically what we do is that we are now introducing bias to a system that previously didn't have one. It's going to be a bias in the other direction, but still a bias nonetheless. Okay, so after all these skeptical, comments I had about some articles, so let's just attack the problem directly. So, do social biases even exist in AI system? And for that, there's a very simple answer. So, of course, I mean, there are all sorts of biases existing in AI systems, especially in deep learning applications. I mean, the very algorithm that we use to train deep learning models, so stochastic gradient descent. Actually, gradient descent would be worse, so stochastic gradient descent is a bit better in this regard, but still it basically just wants to have an as close fit as possible to the training data presented, usually leading to overfitting unless some specific action has been taken care of. And as a result, yes, we do have bias. Now, what kind of bias? Mostly it's turning out as to be an issue of, I don't know, a disproportionate response or a visible error in the prediction system. So there's no indication whatsoever that this bias would be specifically social. It just exists. But the important part of it is that for general applications, practitioners of ML anyway are having techniques and a strong focus on reducing all kinds of bias. So this is something that even without highlighting the importance of the topic is, as I said, it's a fundamentally mathematical phenomena, and everyone who's working in this space would be working on it anyway. Now, I wanted to present a few particular techniques to mitigate bias. So it's going to be interesting to see that actually quite a few of these are relatives to other well-known techniques. So for example, reweighting is not fundamentally different from undersampling and oversampling. So basically here we don't play with the probability of different kinds of samples presented from the training set, but with their weight, so that we are weighting their importance and contribution. And altogether there are ideas like trying to either in an unsupervised way or in a supervised way, trying to hide the features that we believe are sources of bias. So these are techniques we can do pre-processing, which means basically directly on the training set before training was actually starting. And then we have in-processing techniques, which I would say are more like normal regularization techniques in ML. So adversarial debiasing, for example, is a quite clever idea to utilize adversarial attack. Here the idea is to do exactly what those guys did in the retina. So in the retinal scan paper, to have another, so basically train two networks, one predictor and another which tries to predict the feature which we want to ignore basically, and train them in tandem, and they will constantly fight with one another, and as a result we will achieve a better amount of fairness. because ultimately we should get a system which is from which, so after which from the output you are no longer able to predict what was the input feature. And then we have post-processing ideas, which are fundamentally all along the lines of, yeah, okay, we have a biased predictor, but never mind, because we can always introduce some bias after processing, and hopefully that will solve the issue. Now, personally, I believe these to be less elegant, so to say, because with these you can achieve nice statistical results, but they may derail particular examples. So it's important to highlight here that there is a fundamental difference between these techniques, because in reality, it is only pre and in processing that is actually working towards equal opportunity, and post-processing is outcome related. So if you remember our statement about bias and full bias, it should be pretty clear by now that which one is preferable. Okay, so I need to highlight that this is in general a topic that is very early days in the industry out there. So there are some attempts to mitigate this and to detect and mitigate biases with software solutions. So here I highlighted a few, but the main issue is that so far the industry believes that this is something you can attack with a software as a service kind of solution, or with specific software tools, rather than just rather than processes and best practices and auditing and things like that. And the issue with this approach is that although there are some very clearly defined generic structures of AI solutions, so for example, if you're having a predictor that's predicting from one image, then that's a pretty common story that happens for many solutions. However, you cannot actually know if what else may come up, and you will have to have some ability to detect and mitigate bias for everything. So personally, I believe that it's better to propagate, so basically spread knowledge for practitioners rather than offload the responsibility for bias detection to some software-based solutions. But anyway, at least there are attempts. The other thing why this whole talk is quite important is that there are movement. So there is movement on the regulatory side as well. So fairness right now could be seen by companies and AI vendors as a nice to have thing, but at least in the European Union, it is very likely that soon this whole topic will turn into a compliance matter. So the same way as it happened, for example, with GDPR, actually, this can be seen as an extreme expansion of GDPR. So what we already have is the ALTAI guidelines published by the European Commission, which are addressing quite a number of issues out there, from fundamental rights to actual technical requirements for actually, interestingly, much more on operating AI systems rather than developing them. And also they define requirements for explainability of AI solutions so that trust can be facilitated in the industry. And as in general, they are tapping on a lot of topics, but what is painfully missing is as one would imagine, definitions, actual ways to implement these ideas, like practical guidelines. And also it's important to highlight that ALTAI in its current shape and form is a self-assessment guideline. So this is something that an AI vendor, if he chooses so, could apply on her system, but nothing more, basically. Anyway, what ALTAI is effectively a foreshadow, which may come soon, that basically the AI market, one way or another, will be regulated, or at least parts of it, because it's also important to underline that probably your credit assessment or hiring decisions based upon your race or your gender are affecting your life in much more profound ways than, I don't know, advertisement does. So there will be, it's expected that there will be industry-specific differences between the level of fairness that is expected from AI solutions, but this is coming nonetheless. Okay, so few words about us, but very quickly. So as I said, Technolinks is a consulting company, so we are mostly working on, I would say mostly happen to work on deep learning related projects, but we are not classifying ourselves as an AI company. So we just want to offer the best for our clients. So what our real focus is to work on interesting R&D projects and to develop custom IP for our clientele. I highlighted a few topics that we did or are working on. Unfortunately, because of the nature of the work, confidentiality is quite important. Nonetheless, we have some anonymous case studies on our website already. So if anyone is interested, then our profile can be rather clearly puzzled together from looking at these or even reading the case studies. And of course, just as well as we are hunting for optimum, we are hunting for R&D software engineers too. So please check out our career options where we have a bit more profound description of this role. Just as a side note, that actually in this topic of social biases, it has been found that language matters too. So actually, as it turns out, there are more masculine language and more feminine language, and actually this particular role description is meant to be an application of a language that is probably more gender neutral. As I said, it's just a side note. So thank you for your attention, and that's all for me from now.
Thank you. Any question from the audience? I got into my mind, so I heard a talk from these OECD guys on which was very much according to what you said on the biasing. So the story was very simple. So it was like a university exercise. Pupils had to build up artificial intelligence code to decide between domesticated and non-domesticated animals. So the thing is very simple. Just you see the lion, you know what it is. You see the chicken, you know what it is. And they used a very huge database from Google, the pictures to train. And at the end of the day, it came out that everything was worked perfectly. Then someone just uploaded the picture from outside, which was a lion, and it failed. And then they started to dig out what was the problem behind this story. And they recognized that the system learned everything except the proper animal on the picture. So it was all about the surrounding. So when they took a picture of a lion in the zoo, it was domestic because it was in human environment. So it's very, very interesting to see that you can have this bias. You can have these certain categories, but when you focus in the thing that it's either women, man, or black, or white, whatever, you have to. I mean, the system, if it's more stronger, the effect in the background, that's more important in sense of the output, not the person itself or the specific property itself.
Yes, so actually the main reason for this is what I already brought out. So basically what happened there is natural to SGD. So basically SGD does two things. So it wants to fit very strongly on something, and it wants to fit on what is the easiest to fit on. So basically, if in that database the most distinctive features were found in the background, then it's going to attach against background. But actually, it's quite common in computer vision, so similar to that, not specifically to a notable bias, but it has also been found that, for example, like cats and dogs detectors are the early ones, actually quite a few years back, were in reality detecting what kind of animal is that based on fur. rather than structure, because the topologies and training techniques that were employed were basically having a bias towards high frequency detail over to mid to low frequencies. So yes, exactly. That's the thing, that if we just in general do our job better, then that kind of automatically reduces all sorts of biases, including social ones. So yes, that's the takeaway message. Thank you for the question.
I have a question.
Please speak up.
When you make it, when you train the AI, the databases that you are using, like in all the databases that are related with the fields that in which men or like historically have been working more, that kind of thing, like working more, having loans, studying more in university.
Yes.
So it's like all the databases will be biased in that way. Is there like any possibility to, like, it's very difficult to just avoid the error since the beginning, because it doesn't matter if you consider just the 10 last years that changed a lot. There are more women working, for example. Even if you just take that at the end, if the database will still be biased, like
yes.
How, like I am curious about knowing how this is like overcome. Like, because like for me, it's still biased from the beginning, so it's kind of difficult
True.
to try to make it.
So
Easy.
Yes. So easiest solution for that, as I implied, is undersampling. So basically, if you for actually cutting the time window is a good idea on that. So let's focus on the past decade or so as a first step. After that, if you have a database which consists of like I don't know, 10,000 good examples for women and I don't know, 50,000 for men, then as much as it will hurt, then randomly drop 40,000 man samples from the database, and then you have a 10K versus 10K database to start from. Obviously, there will be some impact with a bit less regularization and a bit less accuracy at the end of the day, but as long as you can gather a still sufficient amount of data, then you should be able to do tricks like this. And this is actually fairly trivial to do because you have a clearly distinctive dimension. So you know the gender of each applicant, so you can very easily do this. And after that, on the actual data set, the bias will still be present, but it won't be present anymore in the filtered one.
It's possible to make the I don't know much, but if it's possible to make the machine know that it's like a male or a woman since the beginning.
Yeah, definitely. So actually, that was highlighted out there that what usually the practitioners do out there is the exact opposite. So they, even if in the data the knowledge was available, so there was a gender flag or something, they try to not feed that into the prediction, so that you can avoid because basically the system knows, then in theory it could make decisions based on gender. However, if the system doesn't even know, then again it's in theory it's less likely, and so it won't make decisions based upon gender. However, in practice it can still make decisions which are kind of correlated with past social biases and so on and so forth. So just removing that feature alone is not necessarily sufficient, but you should, as I said, combine things. So you should remove the gender flag from the network, and you should additionally undersample the man samples. So was this a clearer answer?
Yeah.
Okay.
Okay, so I think we have to move because
sure.
people are online still in the queue.
So thank you for your attention.